Hello and welcome. Today we are going to be looking at the motion sensor lab. That's right, the lab that you are doing either today or tomorrow. If you guys are following along with the document from your drive, we are looking at part 3, data recording, and we're going to start with number 1, which is to enlarge the window. So I just did that, and now we are going to study the position versus time graph. After looking at that red line there and studying it, you can answer the following questions just below. And after you answer those questions, like how close should you be to the motion sensor at the beginning? Or for how long should you stand still? All right, answer all those questions and then move on to number 3. Number 3 is when we get to start moving around. Now be careful, make sure there's nobody or nothing behind you. You don't want to run them over and get injured in your physics class. So when we do this, we want to begin by standing, getting into your position. It helps if you guys have a meter stick on the floor. So here I am standing in the right position. We want to have the book here because the sound is going to be bouncing off the book, reflecting back to the sensor. This is much like how bats can navigate at night using sonar. So that little clicking that you sound is not the sensor broken, it's actually the sound bouncing off. So here I am with the book in front of the sensor. Have your partner again press start, which is right here, and here we go. And I want to try to match the graph the best I can, the red line, by moving back and forth. And hopefully you can do much better than that, and you guys will get to know how the lines match up as you go through this experiment. But here we have our data. You guys can run it again with your partners. You don't have to delete this run. If you keep the data here, that's fine. You could always click and drag it over and it will show up. This was a run of me practicing. So I did actually get better, even how bad that is. You guys can turn this into a little bit of a game to see who can fit this red line the best, but don't spend all period trying to play that little game. Okay, so let's take a look at this blue data. If I want to get rid of the red data, I click on it here, hit backspace and remove. So here's my run number 40, and let's go on to analyzing the data. Okay, when we analyze the data, it says to click auto scale. That's this button right here. Click on auto scale and it'll be a best fit line. After that, we then highlight a section that we want to analyze. So here, the yellow here means it's highlighted. These are the data points I want to analyze. And we go to the fit, linear fit, and we have all of this information here. Now what does that mean? Well, in the write-up it'll tell you, but the M in parentheses, like it says, is your slope. So this is the slope of my line, 0.0474. And this R value is how close that I was to the red line. Okay, so we get this data. You want to write this down, record it, and then we move to the next section of data. Again, still having that linear fit. So now we are down on the downsloping line, and we see that the slope is now 0.204. The negative just means that it is going down, right? It's the direction, which means going down, right? Now we want to get to the third section of data, so I'm going to highlight that just in the same manner we did before. We see here that my slope has now been changed to a positive number because now I am going in a line that's up and away from the x-axis, and it's 0.618. My R value is 0.998. So that is section number 3, and then we can end it with this section here following that same process. After you finish that, you could then move to number 4. Number 4, you are going to manually calculate your slope. So if you want, you can remove this data. We just want to be looking at the red line when we are manually calculating it using the speed is equal to distance divided by time. So when you use that equation with your data points here, you can fill in the table there. There's the two sections. So you get your slope M from the best fit. That was from our data points that we just did. Here we have towards the sensor, and then the upward slope is away from the sensor. So you can put those numbers in, and then when you manually calculate it again, this is towards the sensor and away from the sensor, and we are using that equation. Speed is equal to distance divided by time. I hope you guys have a lot of fun with this lab. It's hands-on, moving around. I enjoy it. This little sensor is a lot of fun. So have fun with it, learn from it. We're going to discuss it in class. And again, if you have any questions, ask Mr. Mel, or you can always ask me, and we'll come around and help you out. Thank you guys for listening, and again, have fun with this.